from here, we are going to move on into our next topic, which is Boolean contexts. Okay, so far we've seen expressions that evaluate to numbers, strings, or none, with the case of print. Now, another thing that functions can evaluate to, or anything can evaluate to, is true or false. And we haven't really seen an example of that. So I'm going to go through some easy examples. So let's say I have a number x. Okay, I want to know if this number is greater than 10. I surely hope not, so we get false. Okay, let's say if it's less than 4. That is also false. Is it less than 8? That's true. So these three expressions right here are Boolean expressions. So here are some operators new operators greater than, less than, and those basically define Boolean expressions. If I want to know if x is equal to 5, then we have a new operator. It's called a double equals, and this double equals is fundamentally different from the assignment statement. Okay, so if I have y equals 5, what assignment does is it copies the value on the right to the left, but what equality operators do, like this double equals, it just literally checks whether they're equal. Okay, and that's true. So this is again another Boolean context. Okay, so some more Boolean context that I'll show you. X is great. We can do greater than or equal to by this. So this is true. We can do x less than or equal to, or this is going to be false. What else can we do? Oh, we can check if something's not equal, right? So x is equal to 5, so the fact that it's not equal to 5 is false. And so yeah, that's a quick rundown of Boolean context. So it's anything that evaluates the true or false. So once we have Boolean context, we can then define something new that we can do with functions. So the functions we've looked at so far have only been able to execute a series of statements. What if we want to make a function make decisions about which statements to execute? So this is some food for thought, and basically the way we do this is we start to introduce conditional statements and control into our programs, basically. So here's an example of the most basic conditional statement. It's called the if, elif, and else statements, and basically it's very intuitive, I think. So what we do is if something is true, we execute it. Otherwise, we check if something else is true, we execute it. It's not required that these are here. So for example, you can have 0 or more else clauses. And then if all of these are false, then we go to the last case. We look at something else. Okay? And this can have 0 or 1 else clause. Okay? So I will go through an example of an if statement to make this more clear. So let's start with a simple example. Let's say I want to know if I'm going to pass or fail a class. Okay? And I'm given a particular grade. If the grade is greater than or equal to 70, then I know I passed. So I'm going to print out a message for myself. You passed. Okay? Now, otherwise, I know I failed. So I'm going to print a message for myself. You failed, with a frowny face for good measure. Okay? So, this is an example of a Boolean conditional statement. So let's load this file up. So, pass or fail. Let's say I get an 85 on a test. Did I pass or fail? I passed. Now, what if I got a 60 on a test? Well, then, oops, what did I do? Oh, I made an error in that I said pass or fall instead of pass or fail. It's not good. But yeah, pass or fail 60 is you failed. Okay, so next, let's see so another function we can do, the classic Boolean function, is the natural. If we want to define our own absolute value function, even though it's built in, given a number, what we can do is we first check, hey, is the number greater than 0? In which case we just return x, right? Else if the number is equal to 0, we return 0. And then otherwise, we return the negative of that number, because then we know it's a negative number. So we just return negative x. Okay? So let's see if this works. So every time you make changes in a program, you have to reload Python, and then start testing basically. So let's say I want to do the absolute value of 5, that works. Absolute value of 0, that works. Absolute value of -10, that works. Okay, looks like my absolute value is working. Now let's do another easy conditional statement problem. If I want to check if a number is positive. Okay. Now, how do I do that? I check first, is n greater than 0? Then I return true, right? So this is a very intuitive way to solve it. And here I actually don't need an else statement. I can have an else statement if I want to. That's fine. But I don't need one because if it's not greater than 0, I know it's false, right? So I just return false straight up. So let's test it. Actually, yeah, let's test this. So is positive on positive number should return. Oh my god, second time I made a typo. Unacceptable. Is positive 5. Okay? Is positive of -5. Okay, this is getting ridiculous. What am I doing? Oh. Bad Napoon. Bad Napoon. Okay. Then let's check 0. That's true. I mean, sorry, that's false. 0 is not a positive number. Okay. Now, let's do another example. Oh, actually, I have a question for you guys. I claim that there is a better is positive function, okay, that can do this in much shorter code. Actually, it can be done in one line. So I want you to think about if there's a way we can modify this definition such that this function can be written in one line with a single return statement. So take a moment to think about that, and I'll spoil the answer right now. So let's say we have a number, right? 5. We want to know if it's positive. How can we check that? Well, at the end of the day, we just check if it's greater than 0. So any number, well, if it's negative, we check if it's greater than 0 and it'll return false. So what we do is we simply just return n greater than 0. Okay? Now, so let's just make sure it works. Every time you write a function, it's good to test it. In the interactive interpreter, I'll be talking about better testing ideas and philosophy in a later lecture, but for now, this is what we got. So let's test our better is positive function. Positive. So this should return true. -10 should return false, and then of course the 0 case, just to make sure, should return false. Okay, so we've gone through basically a huge rundown of a lot of conditional statements. So I hope you guys find this quite intuitive. Just do some more practice and it should be very clear how they work. So the execution rules for a conditional statement, basically we evaluate if the condition in the if statement first, and then we check if it's a true value, we execute the body. So here, if x is greater than 0, we execute the body, and we don't even worry about the rest of it if that's true. If it's not true, only do we go to the next part. Okay? So that's basically how conditional statements work. So one last thing I want to note about Boolean context, there is a little bit of a idiosyncrasy in that statements such as x is greater than 5, x does not equal 10, they're pretty intuitive in that they evaluate to a true or false value, but Python has this weird thing where they, in Boolean context, 0 is actually a false value. I'll show you examples of this later, but if you put if 0, it's going to be if false, basically. And then the empty string is also similar to this, and none is also a false value. So be aware of this. I'll do some examples of this, but I just want you guys to be know that this is a thing. Alright, the last thing we'll talk about today is something very exciting and very, very useful. It's called iteration, and basically the foundational question for iteration and why we want to do it is like, what if we want a program to execute a statement multiple times? Okay, and to do this, we use a while clause, and the syntax for that looks like something like this. While we have a condition, we continue to execute this suite until the condition is not true anymore. And one thing you want to be aware of is infinite loops, and that's something I'll talk about briefly, but also much more in depth and later on in the course. So let's now define some simple functions. So let's say I want a function that will count down from a number, okay? And I want it to print all the steps down, okay? As long as something is greater than 0, I want it to print the result, print n. And then one thing I want to make sure is I want to make sure each step that we're decrementing down, because I want to count down, remember? And this is important because this is our condition basically. And every single while loop is made up of some type of initialization. In this case, the initialization is implicit in the function call, and then some type of condition, which is termination condition basically. So as long as n is greater than 0, this is going to execute. If it's not greater than 0, it's going to stop. And then it also has some incrementation. Sorry, incrementation is not a word, I think, but you get what I mean. There's some increment or decrement in this case. And here, so we're basically, what this does is we slowly approach our case where this is not true anymore. And now, for example, if I passed in a positive number and I did n plus 1, what I would get is an infinite loop, because no matter what, it's always going to be greater than 0, right? So this will never end. And those are quite annoying to deal with. So be aware of those. And yeah, so let's test this. So basically what we're going to do is we're just going to count down. Let's say I want to count down from 5, and I get 5, 4, 3, 2, 1. All right, great. So another easy function to define is the count up function, and it's basically very similar to our count down function. But here we're going to actually have an initialization, in that I'm going to initialize a variable I to start at 1, right? Because I want to start at 1, and I want to say while I is less than or equal to my ending point, right? I want to print I, and what I'm going to increment is I. So yeah, let me do that, and that's all it is. So let's test this function. And all right, so count up. Let's count up to 5. Make sure we get the right sequence. So 1, 2, 3, 4, 5. Okay, and also before I end this video, I want to show you some handy dandy syntax. So one thing I did here is I did n is equal to n minus 1. One shortcut that Python loves its shortcuts. I can actually do minus equals 1, and this is the same thing. Oh, by the way, this is a comment. I'm adding a comment. I'm saying this is the same thing as n is equal to n minus 1. And here, what I can do is I can do I plus equals 1. So this is ways to shorten our code a little. They basically do the same exact thing. So I just want you guys to know what this is. So let's just, for those of you who don't believe me, let's test our code. So count up 5 does that, and count down 5 does the same thing. So that's all I have. So basically, iteration is very, very powerful. So I don't think there's ever been a single program I've written recently that hasn't used iteration, because you always want to you never want to do something only once. You want to do something several times with changing conditions, and that's how you sometimes run experiments and stuff. So it's very intuitive that iteration is a very important idea. And with that, that's all I got for this video. Thanks for watching. And the next video, we'll start getting into some really cool stuff. Not that this stuff isn't cool, but even cooler stuff. Okay? So that's all I got. Thank you for your time.